the 19th century, mathematics underwent great change and development across Europe. During this time, many new ideas in geometry, analysis, and number theory emerged, reshaping the directions of the modern mathematics. Countries such as Italy and Germany became the centers of learning where scholars exchanged discoveries that influenced the scientific world. One of the mathematicians who lived during this era was a remarkable figure from Germany. Theories later influenced scientists all around the world and played a crucial role in shaping the modern mathematics. To understand his impact, let us begin our journey by traveling to the place where he lived and worked during the 19th century. We have now arrived in Germany. This is where one of the most influential mathematicians of the 19th century spent much of his life. Here, he studied, researched, and developed ideas that continue to shape mathematics today. And now, let us all meet him. This is Bernhard Riemann. Bernhard Riemann, on 1826 to 1866, was one of the most influential mathematicians of the 19th century. Born in Brazilian Germany, he grew up in a modest family but showed exceptional talent in mathematics from a young age. He later studied at the University of Göttingen under the guidance of the legendary mathematicians Carl Friedrich Gauss. Riemann lived during a period of rapid mathematical growth in Europe, especially in Germany and Italy. His groundbreaking ideas transformed the fields of analysis, geometry, and number theory, shaping the directions of modern mathematics and physics. Many of his concepts he introduced remain fundamental today. The major contributions of Bernhard Riemann. First is the contribution to analysis and complex variable. Second is the contributions to geometry. Third is the contribution to number theory. Let's talk about first the real analysis and complex variable, Riemann integral. He created the first rigorous definition of the integral. Now he called the Riemann integral, which became a foundation of calculus. Riemann surfaces. He introduced Riemann surfaces, geometry objects used to study complex functions. This allowed mathematicians to understand complex numbers and functions in a visual and intuitive way. Fourier series and function theory. Riemann investigated conditions under which a Fourier series represents a function. This work helped clarify the nature of convergence and laid the foundation of modern harmonic analysis. His research motivated future mathematicians to develop more rigorous definition of functions, limits, and continuity. Let's move on to geometry. Differential geometry. In his 1857 lecture on the hypotheses which lie at the foundations of geometry, Riemann introduced Riemannian geometry, a new way to study shapes, distances, and curved surfaces. He generalized geometry from flat Euclidean space to curved manifolds, where space itself can be bent and stretched. Manifold. A manifold is a space that looks flat in small regions but may be curved globally, like the Earth's surface. Riemann created a mathematical framework for manifold using matrix, tensors, curvature, and geodesics. The last contributions of Bernhard Riemann is the number theory. Riemann zeta function. The zeta function is a mathematical function that encodes deep information about prime numbers. Riemann extended it into the complex plane, complex numbers using a method called analytic continuation. This leads to a new field of study combining analysis and number theory. Riemann hypothesis in 1859. Riemann proposed a bold statement about the location of the zeros of the zeta function. This statement, called the Riemann hypothesis, predicts the pattern of prime numbers. It is one of the most unsolved problems in mathematics. Analytic number theory. Riemann's work on the prime counting functions, the pi times x, connected prime numbers to complex analysis. He showed that the behavior of prime numbers is tied to the zeros of the zeta functions. His ideas created the field of analytic number theory, which remains central in number theory research today. Let's dive into the influence during the 19th century. Riemann's ideas spread throughout Europe, especially in Germany and Italy. Italian mathematicians adopt his theories, strengthening their mathematical traditions. His work reshaped geometry, analysis, and number theory, influencing scientists and mathematicians worldwide. In summary, Bernhard Riemann was a 19th century mathematical genius whose concept continued to guide modern mathematics and physics. His contributions in geometry, analysis, and number theory have left a permanent mark on scientific history, making him one of the greatest mathematicians of all the time. Through the study of his life and contribution, we can appreciate the importance of 19th century as a period of discovery and lasting impact of one of history's greatest mathematical minds. Thank you and happy watching!